On the 12th of August 2026, scientists from all over the world will come to Spain and Greenland and Iceland to witness a solar eclipse. But with space missions which can already dive into the sun and observe the sun 24/7, what is the point of a solar eclipse for a scientist? Is it just an excuse to come to Spain and enjoy summer? We're going to discover it today. If you're new to the channel, welcome back to Boring Astronomy. I'm Alessandro, your astronomer next door. I have been in astronomy for the past 20 years and I'm here to share with you some of the things that I learned along the way. If you're on this channel, you probably have some idea of what a solar eclipse is. And we've been witnessing this phenomenon for hundreds of years, and by now it's quite well understood. And here is a visualization from the European Space Agency. Basically, a solar eclipse is due to the moon being in front of the sun with respect to Earth. And because of the size of the moon, the size of the sun, and the distance between the moon and the Earth, and the sun and the Earth, what ends up happening is that the shadow of the moon on the surface of the Earth is very, very small. And this allows us to just see the disk of the sun completely masked by the disk of the moon. And this is a remarkable coincidence of nature. It is fair to say that we will probably have no idea about the external part of the sun if it wasn't because of eclipses. This spectacular part of the sun that we are only able to see during an eclipse is called the corona. In fact, in astrophysics, there is an instrument which now we use routinely on other stars to block the light from the star and to be able to see the surrounding of the star, and we call it a coronagraph. All of this began because of solar eclipses. But why is it so special? The thing is, the corona is very faint and the sun is very bright. So if we want to see the corona, we have to block the light of the sun. And if we try to build a coronagraph, the coronagraph will try to block the light of the sun, but some light will be reflected, diffracted, scattered, and will always pass through our instrument. The moon works as a natural coronagraph, is far away in space, and is really a perfect coronagraph. This beautiful coincidence I was talking about is that the angular diameter on sky of the moon is almost exactly the angular diameter of the sun. So this means that when the moon is in front of the sun, we are able to see all the way almost to the surface of the sun. We may make a complete different video about the concept of surface of the sun. This is a very fascinating and extremely complex topic. But basically, the main plasma of the sun and the actual atmosphere of the sun stops very much behind what the moon will be blocking on the 12th of August. And then we start to see all the events which happen on the surface of the sun. And then there is the corona. So all these parts, they're only visible during an eclipse. So we are basically putting together data that we can take out of the eclipse of the sun itself, the data from the eclipse of the corona, and then data of missions which can fly close to the sun, like the Parker probe. One thing that I didn't know, and I discovered researching for this video, is that the European Space Agency has a mission which can perform its own artificial eclipses in space. The mission is called Proba3, and this is really how it works, and is comparatively easy. It's really like a minute Earth-Moon system where the coronagraph is flying far away from the detector and literally creates an artificial eclipse. Are we done with eclipses on Earth? Well, not quite. This is a composite video of a coronal mass ejection as seen from SOHO, which is a very famous solar observatory in space. It's a NASA ESA mission, and SOHO sees the red part here. Proba 3 sees the green part here, but you can see the yellow part is not probed by either. And you can see this yellow circle. It's not a yellow circle drawn there. That is the limb. That is the surface of the sun. And this area between this yellow circle and the beginning of the green circle, that is one part of sky which is only accessible to us during eclipses. But why to do all this mess for just that little bit? Well, that little bit is the place where the corona is launched, where the coronal mass ejections are created. That is where a lot of interesting and not well understood science is happening. We can use instruments which normally we would use on faraway stars, and we can point them at specific parts of the sun. So we can use spectrographs, we can use narrowband imagers, and we can actually see at very high resolution what is happening. We can use spectropolarimeters to have an understanding of the direction and the intensity of the magnetic field of the sun and of the corona of the sun, and to see how it's evolving. And you probably heard that the eclipse only lasts 1-2 minutes, sort of depends where you're staying, but you can play tricks. You can place copies of the same instrument along the path of the eclipse, and in that way you can get, instead of 1 minute, you can get hours of observations of the sun using the instrumentation for the science case you're interested in. And in this way you're going to be able to make a movie of these hours of observation, and this movie you can then contrast with models. And I heard that the Instituto de Astrofísica de Canarias is in a collaboration with a university in the US, I think from San Diego, to use the data from this observation to contrast models that have been developed in the US. You can also study how the Earth responds to all of a sudden not having illumination from the sun. So we can study the behavior of the upper part of the atmosphere, which all of a sudden doesn't get solar illumination with respect to the surroundings, which still are illuminated from the sun. And we can study how radio waves behave when these parts of the atmosphere receive a different amount of solar radiation. And we can study the meteorology and how the weather reacts to this sudden drop in temperature. And we can study the behavior of animals. There was a video which was super cute a few years ago of a series of chickens, which I think was an eclipse which was observable from Svalbard or something. And these chickens, they saw that it was getting dark, and they went back to their house, and then the eclipse finished and the sun came out again, and the chickens came out again. It was absolutely gorgeous, and sort of allows you to probe into the behavior of animals who are not capable of predicting eclipses and don't have the understanding of the eclipse, how they react to this sudden change in illumination. So in summary, solar eclipses are still a very useful astronomical tool. We are taking advantage of an extraordinary coincidence, and we're using an extraordinary astronomical instrument, which is the moon acting as a coronagraph. For many people, it's going to be just a fantastic show, and for some people, it's going to be a few minutes of intense, very hard work after years of preparation. And I'm sure that the results are going to be fantastic. And why not? At the end of the day, we're also going to get a lot of beautiful images. So I hope you liked it, and I hope you will enjoy the eclipse wherever you are. Even if you cannot come here to Spain and watch the eclipse, a series of observatories are going to show a live stream, so go watch it and enjoy it. And I'll talk to you next time.